Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll be discussing solutions to problems in the second paper of the 2013 JEE Physics Advanced Question Paper. I'll be working with code 0, but in any other codes the question will be the same, just the order will be shuffled, so you can figure that out for yourself. The 15th one. Now the 15th question is completely straightforward, 15 and 16. But you need to make sure you make the calculations properly, right? The basic point in that is this: if something like A plus B plus C forms D plus E plus F, then the mass of D plus the mass of E plus the mass of F should be smaller than the mass of A plus the mass of B plus the mass of C. If this mass is smaller, this energy is smaller than this, which means energy is released in the process. Any process in which energy is released happens on its own. Any process in which energy is absorbed, we need to make it happen. Right? So if this is true, that means it can occur, otherwise it cannot occur. So the first question is, the first option for 15 is, let's look at each option separately. Lithium can emit an alpha particle. So that would mean 6,3 Li emits an alpha particle 4,2 plus what is left? What is left is a 2,1 hydrogen. Now you are given the masses of all three, and if we actually calculate the masses of all three, these two have a greater mass than this. If this has a greater mass, this has a greater energy, which means it can never happen. I'll write the equations for all of them. You can calculate the masses yourself. Right, 2H1 has a mass of 2.014102 and 4He2 has a mass of 4.002603. If you add them, it will be greater than the given mass of 6,3 Li. So B, polonium emitting a proton will be 210 PO84, which goes to 11 H, which is a proton, plus 219 83 209 83 bismuth. You calculate the masses, you'll see that this is again not possible. These two have a combined mass greater than this one. For C, deuteron and alpha particle, 2H1 plus 4He2 goes to 6 Li3. Now you don't even need to do anything here. We've already seen that the first relation cannot occur because the mass of two of them is greater than the mass of the third one. So obviously this relation can occur, right? This relation is possible. It's the inverse of the first relation. So C is true, and D is 7030 Zn plus 8234 Se becomes 15264 GD. You'll see that the mass of this is greater than the mass of these two, so it cannot happen, which means the answer to our question 15 is option C. Let's see question 16. The kinetic energy when polonium undergoes alpha decay. That's again straightforward. 21084 PO goes to 42He plus 206 82 PB. This is MP. Let's just call it MPO. This has a value of 209.982876. And these two have a value of MHE is 4.002603. MPV has a value of 205.974455. So the answer will be, we'll add these two together. That gives us 209.977058, and we subtract it from the first one. That will give us delta M, which will be 0.005818, and we'll just multiply it by C square to get the total energy, which will be delta M C square, which is this multiplied by 932, which is 5422 kilo electron volt. This is the energy. Now this is not the final answer, right? This is where some people might make a mistake. This is the total energy given, right? That means this is the kinetic energy of helium plus the kinetic energy of this term. Both of them have a kinetic energy, but both of them will have the same momentum because of momentum conservation, right? So the momentum for both of them, let's call it P. Then the kinetic energy for this will be P square by 2mhe, and this will be p square by 2mpb. And the sum of the two of them will be this value, let's say alpha. And if p is the same, then what will be each of those two terms? Right, they will be inversely divided in the ratio of the masses. So the first term, let's say this is A, this is B, right? So the first term will be alpha into, see this is much greater than this, right? So this will have a greater contribution. So this will be m times pb. You can just straight away solve it, but I'm used to doing it like this, by mhe plus m, which is equal to whatever this energy is into the mass of pb by the sum, 206 by 210, which gives us exactly 5319, which is option A, which means the answer to our question, which is option A. So this is the important thing. This is why they gave the question, I think. Otherwise it would be too easy to come in IIT JEE. But you just see this and you see that this is the total energy divided in the ratio of mhe and mpb such that momentum is the same. So you calculate the kinetic energy of just the alpha particle. Most of it will be the kinetic energy of alpha particle, but a little bit will go into the kinetic energy of lead as well. Right? Thank you.